What's up, nerds? Today I wanted to talk about uh, Portal 2. For all of you super nerds out there, you know already that I played Portal 2. And through my playthrough, I saw the sign on the wall on one of the levels that listed a bunch of paradoxes. One of those paradoxes completely misrepresented Russell's paradox, which is what I'm going to explain to you today. For those of you who haven't seen that part of the video, here it is.
Paradoxes. No AI can resist thinking about them. I know how we can beat him.
That's really funny. In the event of a rogue AI, stand still, remain calm, scream. If this statement is false, new mission, refuse this mission. Does a set of all set contain itself? Actually, that's not the paradox. So that's referring to Russell's paradox. Brief lesson in set theory, in logic. So a set is just a group of things. So you can have the set of all candles, or the set of all potatoes, or the set of all words that start with P, or the set of all prime numbers, or the set of all anything. You can have any kind of set. So the set of all sets isn't a paradox, because a set can have itself as an element in that set. So that's fine. So consider the set of all sets that have two or more elements. Well, that set would have two or more elements, and so that set would be a part of itself. This statement's right there. Does the set of all sets contain itself? Yes, it does. But that's not what the paradox is. So some sets, like the set of all red things, aren't elements of themselves. So, well, because the set isn't red. But other sets, like the set of all things that are not red, are elements of themselves, right? The set is colorless, so it's not red, so it's part of the set. Consider the set of all things that do not have themselves as an element. The set of all sets that do not have themselves as an element. So like the set of all prime numbers doesn't contain itself, because the set itself is not a prime number. The set of all sets that do not have themselves as an element. Well, let's call that set S for set. So set S is the set of all sets that do not have themselves as an element. Well, if that set does not have themselves as an element, then that is an element of itself. But it can't be an element of itself, because we've defined the set as the set of all sets that do not contain themselves as an element. So that's the paradox. So does a set of all sets contain itself? Yes. That sentence is not the paradox. The paradox is the set of all sets without themselves as an element. That is the paradox. So boom, Portal 2, you just got philosophized. So yeah, just to recap, essentially set theory is a theory in mathematics and logic that focuses on what we call sets, which are essentially just collections of things. Anything really could be a set. You can have the set of all red things, you can have the set of all words, the set of all words that start with the letter P, the set of all numbers, the set of all prime numbers, the set of all prime numbers that are 3 digits, the set of all things that aren't in my living room. So there are infinitely many sets and infinitely many kinds of sets. And so, yeah, as far as mathematics and logic go, mostly we're concerned with sets that apply to those disciplines. So sets that have to do with math and logic, arithmetic. Pretty much everything we talk about in math can be explained through set theory, at least in the language of set theory. And so it was kind of a big deal when this guy came along, Bertrand Russell, and sort of flipped set theory on its head, and made logicians and mathematicians have to take a step back and axiomatize set theory. And the paradox is pretty straightforward. If we consider different kinds of sets, so let's say the set of all fruits. Anything that's not a fruit does not belong to that set. So a carrot does not belong to the set of all fruits. We can go so far to say that the set itself, the set of all fruits, is not an element of that set, because the set is not a fruit, so the set does not belong in itself. However, if we consider the set of all things that are not fruits, the set is not a fruit, and so then that set would be an element of itself. So now consider the set of all sets. This is where Portal 2 goes wrong. The Portal 2 assumes that the set of all sets is a contradiction, is a paradox, but it's not. A set can be an element of itself, like in the case of the set of all things that are not fruits. So the set of all sets can be an element of itself, so itself is a subset of itself. And as weird as that sounds, it's not logically inconsistent. It is perfectly acceptable. The problem arises when we take it one step further. Consider the set of all sets that are not elements of themselves. If the set is not an element of itself, then it belongs in itself, which then would make it an element of itself, which would then disqualify it from being an element of itself, and you see the paradox there. So Portal 2 is wrong, and they don't understand what Russell's paradox is. So anyway, now that I've gotten my nerd rage out of my system, if any of you are interested in watching me struggle through some basic puzzles, I will link to the videos. But other than that, make sure to like this video and subscribe to my channel, and that will be all. See you later, nerds.